Hey everyone, welcome back. In this video, I'm going to talk about solving exponential equations. We'll go over a general strategy and then go ahead and apply that strategy to a few examples. And so the first thing that we are going to want to do is to isolate the exponential if it is possible to do so. And so that's kind of what we see in this example that I have up already. By isolate the exponential, we mean get the exponential on one side of our equation all by itself equal to just a constant number on the other side of our equation. So after we have isolated the exponential expression, got our exponential equal to a constant number, we then want to take the common or natural log of each side of our equation. It doesn't matter which base we use here, but we have to be consistent. So if we take the natural log of the left-hand side, we have to make sure that we use the natural log on the right-hand side as well. Once we've taken the logarithm of each side of our equation, we then want to simplify the equation using that power property of logarithms. That's going to allow us to take our variable out of the exponent and bring it out front in a place where we can solve for it. And that's our final step. Usually do some division or a little bit more manipulation, move things around, solve for your variable, and then you have your answer. Maybe you'll approximate it if it is necessary to do so. All right, so let's go ahead and now try to apply our strategy to our first example here. So we're trying to solve the equation 3 to the power of x is equal to 12. The first thing we do is isolate our exponential. That is already done for us. So our next step is to take the log of each side of our equation. And I typically almost always use the natural log for reasons that we'll see in calculus. So we're going to go ahead and take the natural log of each side. That gives us the natural log of 3x is equal to the natural log of 12. Now we move on to our third step here, where we simplify our logarithms using that power property for logarithms. We're going to bring our exponent of x out front as a factor on the left-hand side of our equation. And that allows us to rewrite our entire equation as x times the natural log of 3 is equal to the natural log of 12. And so now we just have one step to go. Solve for our variable x in this case by dividing away that factor of the natural log of 3. So our exact value for x is the natural log of 12 divided by the natural log of 3. And now we can input that into a calculator and approximate it. And according to my calculator, the natural log of 12 divided by the natural log of 3 is about 2.26. All right, so now we've seen how we can use some properties of logarithms to help us solve our exponential equations. Although not all examples or problems will be as straightforward as this. Oftentimes we'll have to put quite a bit more work into that first step of actually isolating our exponential. I have another example of an exponential equation that I want us to solve using our general strategy or procedure, and it's going to be a little bit more involved than our previous example. So here we are attempting to solve the equation 5 raised to the power of the quantity 2x minus 1 minus 50 outside of that power is all equal to 150. I have another example of an exponential equation that I want us to solve using our general strategy or procedure, and it's going to be a little bit more involved than our previous example. So here we are attempting to solve the equation 5 raised to the power of the quantity 2x minus 1 minus 50 outside of that power is all equal to 150. And so if we're following the steps of our general procedure, our first step is going to be to try to isolate our exponential, that is 5 to the power of 2x minus 1. So in this case, it's not isolated or alone because it has that minus 50 on the left-hand side with it. So our first step is going to be to add 50 to each side of our equation. And that'll give us 5 to the power of 2x minus 1 is equal to 200. All right, so now we have successfully isolated the exponential part of our equation. Next, we have to take the common or natural log of each side of our equation. So let's go ahead and take the natural log of each side. By doing so, that gives us an equivalent equation that's going to have the same solution set. But now our equation can be rewritten as the natural log of our exponential 5 to the 2x minus 1 is equal to the natural log of 200. Right? We have to make sure we have our exponential isolated before we take the log, because we can't actually split the logarithm up over 5 to the 2x minus 1 minus 50. Our log properties don't work that way. So our next step is to simplify our logarithmic equation using that power property for logarithms. This step is essentially always the same. We're going to take that exponent inside of our logarithm and bring it out front as a factor. And so that allows us to rewrite our equation now as the quantity 2x minus 1. That was our exponent. But now 2x minus 1 is multiplied by the constant number, the natural log of 5. And that's equal to the natural log of 200. And so now to finish this problem off, we just have to solve for x. And believe it or not, this is now just a linear equation that we have to solve for x. The first step I would take here, although this does not have to be the first step, is to divide away by that factor of the natural log of 5. Another possibility is to expand the left-hand side, but I think this will get us there in about the same amount of time. So now we have 2x minus 1 is equal to the natural log of 200 divided by the natural log of 5. Next, I get 2x by itself just by adding 1 to each side. So 2x is equal to the natural log of 200 over the natural log of 5 with 1 added on top of all of that. And our exact value for x is going to be 1/2 times that quantity. So 1/2 times the natural log of 200 over the natural log of 5 plus 1. Now if we have a calculator assist us in evaluating that expression, I got a value of about 2.15. So what is our approximate answer to the exponential equation? 5 to the power of 2x minus 1 minus 50 is equal to 150. Well, here is our exact answer, which is approximately 2.15. So you can check this real quick. If you take x is about 2.15 and plug it into the original equation, the left-hand side should evaluate to about 150. Don't forget, we can always plug in and check our answers.